In today's last exercise, what we're going to do is write a little program together. We're going to implement a function that works with lists and has a little algorithm associated with processing a list. We're going to implement a function named contains, and let's talk about what this function should do. Well, it's going to be a function where we want to be able to give it two arguments. We're going to give it a needle and a haystack, and we're trying to look for that needle in the haystack to determine, does the needle exist in the haystack? In other words, if we have a list of strings, that's going to be our haystack, and we're trying to determine, does some other string, let's say we have a list of names, and we're trying to see if someone is on the list that gets into the party, right? And we have someone's name, and we're going to scan through that list item by item and test. Do we see the name yet? Do we see the name yet? Do we see the name yet? And if we see the name in our list, we'll return true. Otherwise, if we didn't see the name in the list, we'll return false. And we're going to name this function contains. So let's go ahead and dive into a quick example in Python. And so go ahead and I'm going to set up a new Python file named contains.py. Right? And we're going to go ahead and set up a doc string. So the doc string is going to say example of writing a function to process a list. Okay. Now, one of the things that I find valuable when writing functions and trying to implement functionality is just jotting down some notes of what is it we're trying to do in English or in pseudocode, which is like not quite real code, but also not quite English. And then go back and actually write real code that implements that. So we'll use some comments here to say something like, okay, we're going to define a function. And maybe that function, we can talk about what it's going to have, right? So it has two parameters. And it's going to have a name of contains. And it's going to return true if two parameters, and the parameters names were needle and haystack, and returns true if needle is found in the haystack, and the haystack is a list and needle is say string, right? And so you can kind of see I'm just kind of jotting down some high level notes of what it is that I need to do, and this is still at a pretty high level. This is a statement that, this English comment here, return true if and only if needle is found in the haystack. So that would imply false otherwise. We should probably break that down a little bit further. What do we actually mean by this, or how are we going to do this? So we need to test move through each item in list until needle is found. As soon as needle is found, we can return true. So we're just going to move through each item. We know that we can do that with a while loop and an index. If all items have been checked, return false, right? Because if we move through every index and we still haven't seen it, we're going to return false, right? So here we've got sort of a scaffold of what it is that we need to do. I've kind of written out a high level plan. I'm just using some comments. Again, there's no code in this, but let's try actually implementing some of this. Okay, so we need to define a function. How do we do that? Well, we use the def keyword, and the name of this function we see is contains. And we see that we have two parameters, and those parameters are a needle of string type and a haystack of list of string type. And remember, needle and haystack are just names of variables that we're choosing for our parameter names that are otherwise sort of meaningless outside of the definition of this function. But it's useful to try and choose parameter names that when someone looking at a function definition can say, okay, you told me you're looking for, like, needle and haystack implies some relationship there. We're trying to find a needle and a haystack. And the return type of this is what? Well, we see in our notes, we're going to return true if the needle is found, false otherwise. So the return type of this function better be a Boolean. Okay. So we've got our signature set up, and we should also add in a doc string. And it turns out like this line here that we had written as a notes would make for a perfect doc string. So I'm actually just going to cut that line and paste it. So return true if needle is found in haystack. And if we wanted to, we could say false otherwise. Okay. I'm going to actually go ahead and delete the comments that we had, the comments that I had for the name of this function and the parameters, because we've already actually turned that successfully into code. And then I might unindent these 3 lines. So I'm going to select the lines, hold down Shift and press Tab. Okay, so we need to move through each item in the list until the needle is found. Now that's English, but we've kind of seen this before, right? So maybe if we wanted to be a little bit more specific, we will describe what we're going to try and do. Use a counter variable to process each index of the loop one by one. Okay, so our counter variable might be I, and it will be an integer that starts at 0. And the pattern that we've seen in the past is, while I is less than the length of our haystack, right? That's the lists that we are trying to process. And when we're writing a while loop, one of the things that we always want to be sure to do is change our counter variable or change something inside of that loop such that we're moving closer to our terminating condition, which is I no longer being less than the length of our haystack. So I went ahead and added the statement, which is the relative reassignment operator. We're increasing I by 1. And so now we're using this counter to process each item of the loop one by one, right? So I'm actually going to remove that note, okay? So we want to move through each item until needle is found, okay? So how can we tell if when we're looking at index I in this list, what is the item stored at index I? Well, if we wanted to break this down into a number of steps, we could say, okay, the item that we're considering is a variable that's a string type, and it's the item stored at haystack index I, all right? So we're moving through each item. We know that inside of this list, the variable item is going to be the item found at haystack index I, which starts at 0. And each time this while loop repeats, it increases by 1 because that's the last thing that we do down here. Okay, and now we're testing if the needle is found. Well, how do we know if the needle is found? We're asking, is the current item we're looking at, so is item equal to our needle, right? And if so, that means we've found the needle in the haystack, right? Because our current item is the haystack index I. And what do we do here? Well, as soon as needle is found, we can return true, right? And we'll come back to this in just a moment. But remember, the return statement works such that as soon as we encounter a return statement, we're going to take that value and send it back to the caller of the function, and no more work is going to be done in this function call. We wouldn't continue looping. We would say, okay, we found the item we were looking for. Let's return true. And then lastly, we kind of see this note that we made for ourselves, which is if all of the items have been checked, meaning we've gone through the entire list and we didn't see the name, we didn't see the needle we were looking for. That means we didn't find the name, and we can return false. Right? Now, we want to be careful here. Do we want to write our return statement at this level of indentation? No, right? Because this is inside of the while loop. If we did this, as after increasing I by 1, we would return false. So we would check only the very first item of our list, return false. So we want that level of indentation to be like the same as the while loop so that it's outside of the while loop's repeat body. And if we wanted to, we could put an extra line between those two to make it a little bit more obvious. But remember, it's not this extra line that's making the difference, because this would still be invalid and wouldn't be what we want. It's that we are unindenting or de-indenting this line such that the while loop statement and the return statement are at the same line. In other words, we're not putting the return statement inside of this while loop body. So now we've got that. We can actually remove our notes there. And we've got a nice little function algorithm, a function that says, okay, let's test whether or not a needle is contained in a haystack. And it's doing exactly what we hopefully set out to do, and we should probably test this. There are a number of ways that we could test this function. And let me remove this comment, and that will clear up this stylistic concern here. There are a number of ways that we can test this function. I want to show you one that will be handy in the next exercise that you're going to be working on, which is we can actually, after we've saved our program, we can start up a REPL and play with our function directly in the REPL if we import it. And we'll talk about importing in more detail in a few more weeks, but let's just take a preview of this, okay? So I saved my file, and now I'm going to start up a REPL, right? So I start up a Python REPL. And what we're going to do is say from lessons.contains, right? So again, this is corresponding to the directory of that we wrote our program in. So lessons is the directory, and then dot is saying, okay, look inside that directory for a contains file name. So contains is the name of this file, and then we can import a function. So import contains. Okay. And now that we have this contains function definition imported, we can call this function. And so we can say, okay, let's say that we have a list of names, and the list of names is, say, Chris and Khaki, right? And then we have someone who's trying to, and then we can call our function, like say print contains, and then our needle might be, let's try something simple. So Chris, we expect to be true. Does the list names contain the string Chris? And we see that that's true. We can also test with Khaki. So I'm going to run this function again. Print out, does the contains function contain the name Khaki? True. And then does it contain the name Kevin? False. All right. So we were able to use the Python REPL to import this function that we defined in this file in that way. Right? And the way that we did this is just a quick reminder is we said from lessons.contains, which is the name of the file and the directory, just like when you say python-m, and then you give lessons.contains, same idea there. And then we're importing the name of something that's defined in the globals frame. So we're importing the name contains, and we know that contains in our diagrams are globals in this example. And so we're importing that function definition, and then we can call it, all right? So what you have to be careful with if you do work with a function in this way is if I were to change this function definition, it wouldn't be until I restarted my REPL and imported that function that the new definition would actually take shape. So when you're doing this, after you finish testing, be careful to always press the trash can, kill that terminal, and start over if you made changes. Now, we could also write a main function here, and let's just talk about that really quickly. So I'm going to set up a function named main, and it's going to be a procedure, so it returns none, and it's just the entry point of this program. Okay. And we could have tested in kind of a similar way, where we could have said, okay, let's set up a list of names, and list of names was in that example Chris and Khaki, and then we could print contains, and the list that we're searching for is, let's say, Kevin, and names was our was the list that we were using as our haystack, right? So this is the needle we're searching for, Kevin, in our haystack. And what we have to remember is after we set up a main procedure, we always need to add our idiom to the bottom of our file, which says, okay, if underscore name is equal to the string double underscore main, then call the main function. All right, so this is just the idiom that kicks off our program. And so now we can actually run this program as a module and see some output, right? So I added this idiom to the bottom of my file. And let me see if I can make this a little bit smaller. I apologize for the size, but this at least gets it all on one screen here. And now I'm going to try running this program. Right. And so let me see if I can get this. There we go. So Python-m lessons.contains. And we see it's false. And that was, we ran the main function that made use of our contains function. But again, we can still run Python interactively and say from lessons.contains import contains. Remember, this is the name of the file, and it just so happens that we named this file the same thing as we named a function definition contained in the file. We could have also imported main, just as an example. And notice that if I were to call main, that's going to call this main function. We see that false is there. But if I wanted to, because I also imported contains, I could call contains, and I could give it, say, let's say print contains and foo, and the list is hello world. We expect this to be false. And I forgot a parenthesis there, so I got to close my parenthesis, and that's false. I could have also tried, well, okay, well, is world contained in this list that we gave it? And notice we gave it a list literal rather than a variable. And this is how we can test our program. So two different ways that we've seen of testing our program and actually making use of the definitions that we write. We can set up a main function and write the test or write some code that makes use of our function, print some output to let us know if our function is working as we expect it. Or we can start up a REPL and import our functions and play with them interactively that way. Both are valid, both have trade-offs. And pretty soon we'll learn some other ways of testing that is even easier to repeat than this. But for now, I think this is the best strategy you've got in the next exercise for trying to define a function that uses an algorithm to process a list and tests its implementation and its logic. All right, great work on this.